Here we'll do one last domain problem that has a rather unusual case. Here we have a fraction inside of a root. To start off, the best thing to do is to split this into two roots. That just means we'll have a fraction which has root negative x minus 5 on top and root x plus 12 on the bottom. The reason this is different from our other examples is because now we have a denominator root and a numerator root. Now, when we deal with a numerator root, we can use the usual rule that says that the inside of that root must be greater than or equal to 0. However, for denominator roots, we can only be strictly greater than 0. This is because in the denominator, it's not okay for us to equal 0. We'll deal with the numerator root as our part A and the denominator root as our part B. On the numerator root, we'll say negative x minus 5 is greater than or equal to 0. If we add 5 to both sides, we'll end up with negative x greater than or equal to positive 5. If we have just a negative sign next to our x, in order to solve, we'll have to divide by negative 1. Negative x divided by negative 1 just gives us x, and of course the invisible 1. On the right, we'll have 5 divided by negative 1, which gives negative 5. However, since we've divided by a negative number, we will flip the inequality sign. Therefore, greater will become less, and we'll have less than or equal to negative 5. So our first restriction is that x must be less than or equal to negative 5. We'll draw a number line to get us started. We'll mark down negative 5 on the number line and place our infinities. Now we examine the symbol in between x and negative 5. Because we have an equal sign in our symbol, we know we must be closed. And since the symbol points left, we'll shade to the left because this is less than or equal. Therefore, we place a closed dot at the negative 5, shade to the left, and cross out the right side because that will not be part of our answer. Now we examine the denominator, x plus 12, and we'll say strictly greater than 0 because it's the denominator root. We will not include the equals here. To get x by itself, we subtract 12 from both sides, and we'll end up with x strictly greater than negative 12. Again, we'll examine the symbol, and we'll see that the symbol is not equal, therefore it will be open. Also, it points toward the right because it is greater, and so we will shade from negative 12 toward the right. We place the open circle at negative 12, and then we shade in the right-hand direction. However, when we draw, we're going to stop before we hit those red X's. Also, since we know we must be to the right of negative 12, we will put red X's to the left of negative 12 to show that also will not be part of our answer. You may be able to see here that we have a region that fits both criteria. The restriction where x is less than negative 5 and greater than negative 12 is this region that I'm putting slashes through now. This is where the restrictions overlap. Now what we must realize is that only the part where the two restrictions overlap will be our solution set. Therefore, everything that's to the left of negative 12 is not part of the answer. Everything to the right of negative 5 is also not part of our answer. Therefore, we have only one region, and that region starts at negative 12 and goes to negative 5. Since the negative 12 is an open circle, we'll put a parenthesis on that, and since the negative 5 is a closed circle, we'll put a square bracket on that. Therefore, our solution is negative 12 to negative 5, and this is how we deal with functions that have multiple restrictions. Thank you for watching. We'll see you again soon.